Okay, we're going to do factors and factoring. We're already like third lesson in. It's pretty great. We're going to talk about the word factors, okay? I'm going to do a multiplication problem here. 2 times 3 equals 6, okay? This is called the product.
No.
And this up here, these two things that multiply together to form the product are called the factors. Okay, so factors are just the two numbers that multiply together. Okay? So if you're going to be doing the factoring, so now you've talked about factors. So if we're going to be factoring, I'm going to be giving you a number and asking you to find its factors. Okay? Here we go. So if I did 36 and I asked you to find the factors, that would be the same thing as factoring. And so what I like to do to find the factors is I like to start off with 1 and 36, and I write them way far away from each other. Have we done this before?
Wait a second.
Not too bad, right? So your list looks huge, but very good.
Okay, so if I had 36 and I asked you to find the factors, you would be factoring. Okay, so I'll start with 1 and 36. Okay, and I like to write them way out from each other. And then once I do 1, I like to do the next one 2, and I ask, does 2 go into 36? And I know it does because it's an even number, okay?
Right.
And it happens to go in 18 times, and I write them apart from each other. This way we'll be putting them in order, okay? Does 3 go into 36?
Yeah,
It
yes.
does. And the way that you know that 3 goes into anything is you take each of the digits and you add them together. 3 and 6 makes a 9. And if 3 goes into that 9, then you know that 3 goes into the original. Okay?
Yeah.
That doesn't work with every number, but it works with 3, and it also works with 9. Okay? So 3 goes in there. It goes in 12 times. I don't know if we're going to have enough room because 36 is a number that has a lot of factors. 4 goes in. How many times does 4 go in?
9.
9 times. What about, we got 1, 2, 3, 4. Now we're going to go 5. Does 5 go into 36? How do you know?
Because if you add them together, 5 can't go into 9.
Ooh, now that adding thing together only works for 3 and 9.
Oh,
The way
right.
you check for 5 is if this number at the end ends in a 0 or a 5, then you know that 5 goes into it. So if it ends in a 6, it doesn't work. Okay? So 5 doesn't work. We got 1, 2, 3, 4, 5. 5 doesn't work. Now next to 6. 6 times what?
6.
6 times itself. And if you get a double like that, you don't have to write the second one, and you know you're finished.
Oh,
Okay? And so you know you're finished. We'll do another one. If you know you're finished also, if we were to come and get right next to each other, like consecutive numbers like 6 and 7, or if we went 6 and then we tried the next number and eventually we worked up to 9, we know we had ended also. Okay, that's why I really like to do this in order, because it helps me to know if I'm done.
Okay.
So my factors are 1, 2, 3, 6, 9, 12, 18, and I skipped out that little 0 at the end. Should be 6 at the end, 36.
Okay.
All right, so that's how we do factoring. Have you done that before?
Yes.
Okay. Have we done it together this year? I didn't think so. Okay. And so now, prime. When I gave you 36, we could find bunches of factors. We had 1, 2, and 3, and 4, and a bunches of bunches. But if I was to give you 37,
It's prime
It's
because
prime.
only one in itself can
because
go into
only
it.
one in itself. So if I did that thing, I would only be able to do 1 and 37, and that's all I would be able to find the factors of. And I'd be done, right?
Right.
So that's prime. So if I want to find the prime factors, I want to find all the numbers that are the lowest. I can't break it down any further. I cannot find anything except that number.
Okay.
So they started out with 168. And they want to find the prime factors. And we're going to do this upside down type of factoring.
Okay.
And so, actually, I'm going to read what they said that was. This. Factoring is often used in algebra to break expressions down into basic parts. To prime factor a number, use division boxes or the factor tree as shown in the example, and divide into no more division or whole numbers until no whole numbers division is possible. Then list the factors indicated by the divisor and final quotient of the division boxes or the factors found at the end of the factor trees or the branches. If there are duplicate factors, you can express them using exponents. So let's do 168. And so I'll actually go like this so we don't look at it. And so I know it's even, and I love 2. 2 is like the easiest one if I use 2 a whole bunch. Now, if the higher number you pick, though, that's a prime, Okay, so if we start with higher numbers, it actually makes your factoring go faster, but sometimes you don't know the higher numbers, so 2 is nice. So I can just check to see if 3 goes into this, because I can take 1 plus 6 plus 8, and 1 plus 6 plus 8 is 15. And so I know that 3 goes in, because 3 goes into 15, but does 9 go into this? 3 and 9 are the only ones you can add these things up. So
Yeah.
that's 15. 9 doesn't go into 15, so
Yeah.
3 is going to be good. And 9 is not prime anyway, so it's
Yeah.
good. So if we take those out and we pick 3, I like picking the a little bit bigger, and 3 is easy, not too hard to check.
Yeah.
So 168, 3 goes into the 16 here. It goes in 3 times, 5 times, excuse me, with a little, I'm going to put my remainder just so I can see that that's 18. And then I have a 6, so that we knew it went in anyway. So 3 is nice, and now I can maybe use a 2. But 56, I know 9, not 9.
6, no, 8.
8 and 7,
Seven.
and 7's prime. So that's nice.
And then
So
2.
and 2, and
4.
4, and
And then 2.
2, and
2.
2. Okay. So here are all my prime factors: 3, 7, 2, 2, and 2. And we can't just, they want to write it out as a nice answer. So when they're writing your answer, it doesn't really matter what order they go in. We can list our 3 and our 7, and we put the multiplies in between, showing that we multiply them together.
And then.
But these 2's we write as 2 to the 3rd power, since there's 3 of them.
Right.
And if you want to check that you have the right answer, take 3 times 7, and then this is 8. And you should get 168 back if you did it all right.
Okay.
So we have found the product of prime factors, because we multiply them all together, and you should get back to the 168.
Okay.
Okay? So if we want to do the prime factors of this one's going to be different because we have letters. So we have 54, x to the 3rd,
Y to the 2nd.
y to the 2nd. Now we can do the 54 with a factor tree. And then we do the variables, we just leave them, because we don't know what x and y are.
Right.
And so we just leave them. X to the 3rd is just x, x, and x, which is still x to the 3rd, so we just leave it as x to the 3rd.
So we do the prime of 54 and then just put x to the 3rd and then y to the 2nd after it.
That's right. So then let's do the 54 here. 54. What numbers do you know for sure go into 54?
Well, 9 does, so that means 3 will.
That's right. So 9 goes into there how many times?
6 times.
6 times. Okay. So neither one of those are 9 and 6. Neither one of those are prime. So we can use 3 because you said 3 goes in there. Okay. And then when you're doing this method as opposed to this tree, you have to pick prime numbers out here. Okay? But when if we would do the tree, you don't have to pick these prime numbers. We know 9 and 6, so we know 3, and I'm going to just do, 3. And we know this is 3 and 2, and so we can be done this way. This way we'd have to pick prime numbers, and now we have to divide. Do you understand what I'm saying?
Yeah, so maybe for this one we'll see that one.
You want to do this one? Okay.
Yeah.
So my answer, so that actually, you can choose between it. Doesn't matter which one you use.
Right.
So then my answer is going to be, I can't really circle it now, because I got to write 3 to the what power?
3rd.
Good. Times 2. And then x to the 3rd.
Wait, but what about that? Oh, yeah, because they're not prime. Not
That's
prime.
right. And we broke the 6 down into these 2. Okay?
Right.
All right? So this are my prime factors. And we can put dots in between those, but we don't have to. Okay?
Okay.
All right. So let's try another one. Let's try one of the problems over here. Let's do like 210 since it's really large. And do you want to do the tree or do you want to do the box?
The box for this one.
What do you know goes into 210?
2.
2, okay. Do you know anything bigger?
3.
3 does. How do you know that 3 does?
Because 3 goes into 21, right?
Very good. And what else goes into 21?
7.
Yes, 7's a really nice one. Then you'll be able to break it down easy. Because
Yeah.
it goes into 21 exactly 3 times with a 0 left. That's beautiful. And so what do you want to try next?
3.
3?
Goes in
Okay.
10 times.
10 times.
Then 2
Then
goes
2.
in 5 times.
Yes. And so you could have picked 2. It would have
It would have taken forever.
It might not have, because then we'd have a 7 and a 3, and so we might have just got them in different orders. And so our answer is just 7 times 3 times 2 times 5, and there's no duplicates.
That's nice. These aren't hard.
No, not hard. Not at all. And so pick one more.
Let's do one with variables.
Okay. 20 m to the
second.
second
And
n to the third. Okay. So what do I have to do?
Break down the 20.
Okay.
And just do the tree one.
The tree
because
one?
that'll go faster.
Okay.
And 2 and 10.
2 and 10.
And then 2 and 5.
2 and 5. Okay. So then, how do I write those factors?
2 to the second times 5. M to the second, n to the third.
Very good.
That really isn't hard.
Not hard at all. I think we're done. All right.